Good morning, everybody. My session will be about the design, digitization, and automation within my organization with Atkins and SNC Lavalin. This is about how we are doing our digital delivery process. Before I will go into my presentation, let me introduce myself. My name is Attila Vidra. I'm the digital lead for land development here in the Middle East for Atkins, the group of SNC Lavalin. I have around 15 years of experience in the industry. Out of that, 10 I had here in the last 10 years in the Middle East. Originally, I'm an architect. I graduated back in Hungary, my home country. And recently, I also completed my MBA with Aston University in Birmingham. My specialty is, as my role also indicates, building information, modeling, information management, digital engineering, where I was working on different multi-billionaire projects, implementing BIM and digital strategies, both on corporate and project level. I'm also part of actually member of Society of Digital Engineering in UK, and I'm also a PMP member of Project Management Institute. And I have several certification in terms of BIM, whether this is BIM management regarding the earlier applicable ISO BIM standards, BIM level 2, BS and PAS, or the currently applicable ISO 19650 standards from ERE Academy. I have several certification for different software providers, such as Autodesk and Bentley, whether this is an authoring tool, coordination tool like Navisworks, or collaboration tool, BIM 360 ProjectWise. And I also did some additional courses to enhance my knowledge and experience in the level of sustainability and sustainable business strategy on my course on Harvard Business School. Going into the part of digitization of design in my presentation, I would like to introduce to you our global design framework. This is basically providing a structured information management approach to bidding, planning, and delivering multidisciplinary design projects. When this GDF is followed, it enables project to meet ISO 19650 requirements and deliver better outcome to our clients, as proven on our ISO audits with BSI on an annual basis. And this basically, our GDF is recognized as a standard methodology underlying how planning, design, and engineering deliver services. It consists of series of standards, methods, and procedures that guides the user through the structured and BSI certified information management scheme. By its nature, it is broad and in scope and abstract in detail to capture complexities of interaction required for project delivery and making sure that it provides a multidisciplinary design delivery adhere to time, cost, and quality. Accordingly, based on this framework, we have also developed a GDF implementation tool. You can see on the screen some of this example as live example. Each of the boxes are one project where we don't just utilize BIM related requirements and standards, but also we measure against it. So basically the GDF implementation tool is used by information managers. It tracks GDF process and the tasks that need to take place at each project stage against the project program. And the second part of this tool is GDF assessment tool, which is basically assessing and measuring the performance of GDF process against the expectation established at the start of this project. Another tool from our wider tool set is our Master Information Delivery Plan online tool, or MIDP online tool. This online tool is a deliverable management system that connects technical deliverable data held in CDEs, or Common Data Environment, with program schedule data to provide visibility to all project participants of when work is due and who is responsible for that work. where we are adopting information management led approaches to design delivery in accordance with our global design framework. There is always a requirement for us to develop a master information delivery plan, which is basically a collation of task information delivery plan, as you can see on the screen as well as the second item. Ideally, this kicks off with the task information delivery plan provided by each task team, listing out all of their project deliverable, and then finally it collated into this master information delivery plan as a tool for us, which is based on the specific file naming convention and other requirements of the project. The MIDP tool allows us to do this efficiently. It combines project management, data with deliverable, data drawn from CDE, and it has linkage to project management tools such as P6 or Microsoft Project. The benefits of this tool are accessible web application designed with the user in mind. Security, so it is secure with granular user permission and compliant security model. It is integrated with CDEs such as ProjectWise or BIM 360, and also, as I mentioned earlier, it's integrated with other project management and planning tools such as Primavera, Pre6, or Microsoft Project. It is also efficient in terms of deliverable placeholder creation, and it's a one-click standard deployment. It will ease the compliance and make it easy to adhere to complicated information management standards. And quantifiable progress reporting is provided by this tool, tying together key project management and technical delivery in one place. In the second part of my presentation, I will have some more detail regarding our automation solutions. Among these solutions, I'm starting up with our information management dashboard, which is our clash detection workflow. As you can see, we have utilized different tools and their integration in this process, starting with Excel, with Python, Power BI, and then at the end with the coordination and issue tracker tools such as BIM 360 or BIM Track. The process we have formulated has 3 steps, starting with the clash matrix. The clash matrix help us structure the data and define parameters at an early stage of the project, as per which coordination will be conducted. Standardizing the format help us to define the structure of data we will be obtaining as an output of this process. And then we have an automated process to convert the data from the clash matrix into our clash test for the federation platform, whether this is Navisworks or any other tool. And once we have the tests run, we utilize the set of dashboards with the linkage and integration of Power BI that break down the data so that it is usable for design team to make decisions, or even the project team. In this slide, the clash matrix is automatic. You can see that we are preparing the linkage between the XML and the Navisworks tool. Here, the clash matrix is automatically converted into a clash configuration, which can be imported into Navisworks via the clash detection platform by utilizing the Python-based tool built by our design transformation team. Thus, the clash test and search sets are automatically created in Navisworks, as illustrated in this image. And finally, this is an example, or basically a prototype of our automated clash dashboard by utilizing the available data source, as explained earlier, whether it's from XML or any other data source, and the integration with Power BI. In the final part of my presentation, what I will showcase you is our several varied automation solution in terms of design automation process, whether it's applicable for different stage of the project, such as design development, or it will go further down for more applicabilities for or benefits on all project stakeholder sides, like client involved, asset management, or digital twin solution. I will show you some real life example in terms of video recording what this will entail. The first example is basically an R&D automated sprinkler placement. Here in this video, you will see the steps being performed, how we are placing these how we are automatically placing these sprinklers, with that having a significant time and cost saving on the project, to basically look into optimization and optioneering. We are using generative design to generate various options to distribute sprinklers in a room. As you can see, currently there is a room run in the Revit file, and this is linked to Dynamo, and we are configuring the settings of that linkage. And we will look into the best possible outcomes based on these various inputs or constraints defined by our MEP engineers. For example, offset from wall, distance in X axis or Y axis, or angle of rotation. So as you can see right now, we have run our script, which is coming up based on the criteria, several different options. You can see currently 10 options on the screen. And by choosing the different paths, we can also have a significant impact on the different usage of this tool. And in the next video, which is about automated creation of 3D lighting fixtures from 2D drawings, we will showcase to you that we are importing the CAD files into Revit. And once these CAD files are imported and we are setting the correct coordinate system, we are ensuring that we have correct plane and referencing. We need to remove the view template assigned to this particular title, to this particular block. And we need to make sure that we launch the EDMP application for the automation of this model element. Here again, we have an automation between Revit and the Dynamo script. So we are running the Dynamo script. We are making sure that all the required packages have been installed in our Dynamo script in order to avoid any warnings or any incompleteness in the process. We also make sure that we installed our internal Atkins tool, which is a tracker DLL. And then once this is done, we will run the script. By running the script, we specify whether this is a live or a test model. And after the specification of test model or live model, in this case, this is a test model, we need to identify the codes for this project if it would have been a project-specific live model. But this is a test model, so we are using the selecting imported links, the levels where the fixture needs to take place, and the reference plane for the specified levels. And then we just run the final script. After this script completed, we will go into the model, and we will make sure that all the depth of the views and every view definition is correctly set, that the views and the appearance of each of these elements is being captured as per the requirements. In our next tool, we are showcasing our maintenance insight tool. This is used to monitor asset performance in terms of inventory, maintenance timing, and the related requirements. This is an example of a rail system tool, specifically of the rail track system, where we can set different criterias, and And in this case, we have a clear categorization of each particular asset, as you see it on the screen, in order to create events to capture our requirements regarding asset and maintenance management. So you will see it's measuring all different categorization of performance. And then at the end, we can run also scenario analysis, and we can have a linkage to recently captured point clouding as a reality model. This video is more about asset classification itself. As you can see, we are applying asset classification via machine learning. In this case, this is point cloud, and this is the best available methodology to capture detailed ground reality of any of the asset. This is a point cloud model for a real network. As you can see, this is capturing the site context and not just the track, but also the platform part and the railing of each site context itself. The process of point cloud classification is a manual process, and it requires special skills and software. Data for large network leads to backlog of survey dataset, leading processing, delaying the downstream. So you need to have a back-end solution running with high-end performance to perform all these tasks in a timely manner. You can see the architecture for an AI-based classification on the screen, which will end up helping us and supporting us to classify the different type of assets. You can see an example with the purple, the railings itself, or the pink color is basically identifying the platform. With this helping to classify a simple raw data captured in point cloud, and making sure that we can basically structure and have a framework or a breakdown structure for our assets. In this video, which is about our integrated data management system, we will show you example of asset management, again for client use. After the collect captured information, we have a grid view of assets, different assets, where we can choose one particular asset going into the detail of that asset, which is quite comprehensive. It can attach photos. It is linked in terms of geolocated, GIS system, and we can have also an access to our dashboard manager, which is further detailing each component of this asset, where we link us to the possibilities of creating different scenarios. After creating different scenarios, we will end up having this scenario dashboard, which provides us an executive summary of the scenario results, which is more insight of basically not just having an overall look of these scenarios, but as well seeing the possibilities and later on comparing the scenarios with each other. Obviously, in order to have the scenarios compared, we need to create our intervention strategy and configure it, where you can see some of the details on the screen using, again, our integrated data management system. And once these intervention strategies are being configured and run, then we will have an update on our scenario. And we can have access in different graphical formats to each of these scenarios, or typical scenarios, or even compare scenarios and summarize scenarios regarding the asset phase of the project. It also basically can handle input in terms of not just the OPEX part of the project, but the CAPEX part of the project as well, and basically comparing the two parts or two phases of the project in a scenario graph that you can see currently on the screen, showing even more further detail per scenario regarding our capex and opex, basically content filtered by high-level areas. Thank you for your time. If you have any question, please let me know.